I'll start with a little bit of introduction to Schluter. You shared a little bit of my bio there. Came from the tile industry off my hands and knees. My family were brick masons, and I knew by 10 years old that I didn't want any part of that. Tile was a very similar trade, but indoors and a little more creative for the most part. There is a Mr. Schluter, back to kind of the products are by an installer for an installer. Mr. Schluter still runs some contracting crews today in Germany, even though the company's gotten as large as it has. He started contracting in '66, and the L angle that most people know finishing tile with, that was the very first product. Today, there's a little more than 7,000 products in the catalog. So, headquartered in Iserlohn, Germany. These are the countries we're in around the world, and less focused on what we are in as to show where we are not, kind of a thing. We don't go into countries that don't have industry standards or governing bodies. We try to do the right thing with everything. So this is our North American presence. It started in Plattsburgh, New York. Started in Montreal. Plattsburgh is our headquarters now in North America. Toronto, Reno were added, Vancouver, and Dallas is our most recent distribution facility. So, moisture management and tiled showers. When we get to this, we're really talking more about moisture management than just waterproofing. And we'll see why in a minute, how some of that comes about. So, some of the benefits to tile, durability of it, it's very durable once it's installed correctly. We can install a tile here. I could drop a bowling ball on it, and the tile should not crack if it's installed correctly. The top may chip, but the tile itself, if it's installed, should not crack. It's a very durable product. It's also got some other properties with heating and cooling kind of attributes to it. Most people know R value, how well something insulates. The flip side of it is K value, or how well something absorbs energy. And there's nothing better than ceramic on the planet, they say. It's the reason your foot feels cold when you step on tile. It's absorbing the heat straight out of your foot. So it is a very durable product. It's also very hygienic. There's no VOCs or organic material in the tile themselves, and really easy to clean. Be easy to clean. Really just mild soap and water is what we should be using, not the harsh chemicals for it. And really the worst offender is probably the Clorox bleach products that we use to clean bathrooms with. They do a great job of cleaning the surface of it, but with Portland products in particular, the bleach gets in and breaks down the Portland, and it actually opens up the pores, which get larger and larger and accumulate more soap scum and more soap scum. So it kind of feeds or creates the very environment that we dislike about tiled showers, those moldy corners, inside and outside corners. So it's also a very versatile product. There's literally tens of thousands of shapes and sizes and configurations with it. And with mud work and some other products that are out there, we're really only limited to what you guys can create, whatever thought you can come up with. It tends to have a high-end appeal, and you're seeing in these pictures, we are now seeing tiles that are 5 foot by 10 foot in size, 1/8 of an inch thick porcelain panels. And it really opens up a lot of the things we've disliked about some tiles in general over the years with the grout joints. So you can do an entire wall with no grout on it, just in the corners or seams. And with some of the printing technology, we were talking about 3D stuff printing earlier, you can really print this carpet or just about anything on a tile and have it installed and not know the difference in it versus a wood look tile. Maybe that might be a good example of it. So it's always assumed that tile is a very expensive product. And when you look, this is a material type, installation cost, and then all the way over is the cost per year when we go through the life cycle of that product. And if you look, tiles around $1 a foot per year when it goes over the life cycle. Yet when we get to carpet, VCT, these other materials, they're 2 and 3 times the cost of what tile is over the life cycle of it. So uh, it's not always a fair comparison to just say it's a more expensive product. So, does anybody have a guess on how much water passes through a shower in a year's time? One shower. No guess. It's a few thousand. One shower, 4 square foot shower with a average flow rate of 2.5 gallons a minute, 12 minutes a day is about 11,000 gallons of water a year. And that's kind of a big number, but hard to wrap your head around. This guy that did the study actually takes it a little further and equates it to inches of rainfall. And so we're looking at 1,100 inches of rainfall equivalent inside that one shower footprint for one shower a day. And I don't know about you guys, but I have 3 daughters, and a 12-minute shower does not exist, and neither does one a day. Absolutely, you're right. That's one shower a day per person, right? 12-minute shower, one shower a day is 1,100 inches of rain annually. That's roughly what that equates to. That's a lot of water, right? Inside where we have all that moisture sensitive product. That's exactly why we're worried about it. If you compare it to what we're looking at inside with that shower versus what we see outside, everybody assumes that Seattle's a very rainy city, but I guess it's just misty, foggy kind of all the time. It only averages about 36 inches a year of rain. And if you look at the map of the U.S., it's really the coast, Gulf Coast, that has the highest percentage. And even there, we only see about 60 or 65 inches of rain annually. So when you compare 65 inches of rain to 1,100 inches, and you look at what we do to the outside of a building, it's crazy that we're having any discussion about waterproofing being needed inside the house. And I'm going to pick on Florida for a minute. We kind of get the black eye. We are the only state left that does not have a pan liner requirement. As long as the slab shower footprint is recessed, the thought being that if it leaks, it just goes into the ground. And that makes sense on that level, but it's not very hygienic, right? And if you think about the purpose of a shower, it's really a human dishwasher. So hopefully everybody's washing all parts of their body. Everything goes into that assembly, and it's really just a cesspool at that point. Tearing them out, if you've ever torn them out, I've torn showers out that haven't been used in 6 months, and there's an inch or two of water in the bottom of it constantly. It has a horrible smell, a unique smell, right? It's everything that gets done in the shower. That's what that assembly is going into. So hopefully we're going to get that changed at some point. But the other reason being all these other products, the drywall, the wood framing, any of those are all moisture sensitive products that we should be a little more concerned about. Partly because of the way construction has evolved. If you think back 30, 40, 50 years ago, we didn't have house wraps or Tyvek or spray insulation. If moisture got into the wall cavity, it just dissipated. Now we are sealing everything up so tight that it has nowhere to go, and it just creates a kind of a perfect environment for this to happen. Or lack of, right? That's kind of where it goes. This is a common complaint for a contractor to get called out saying, hey, my shower's leaking, and they want to recaulk it. Caulking or sealer or grout or tile have nothing to do with waterproofing a shower, and they should be able to use it without any tile on it. So this 3-year-old shower wasn't leaking. It was more of a smell issue with this. And a couple things to point out with it. The Tile Council of North America is the governing body that we have. We don't really have tile police, but we have standards that we go by. We're supposed to have 95% coverage on the back of a tile in a wet area. Otherwise, we create pockets for water or moisture to accumulate. If you look at this bench, the only place that has any coverage was this. All of these notch trowel ridges that you can see are just valleys that accumulate all that mold and soap scum and everything else that gets in there. And when you took the top off of the bench, it was very nasty, and this is where the odor was coming from. This is back to that cesspool kind of a thing. So trying to differentiate between moisture management and waterproofing. This was waterproof. It's really just a swimming pool type application where we contain the water in the bottom of a shower, but we're building it with wood framing or cement backer board. It's real hard to see, but there are nail heads here that are penetrating the waterproofing all the way around the bottom of the shower pan itself. So tile or grout are not waterproof, and we need to be able to let water and vapor go through that assembly without affecting it, without affecting any of those materials. The vapor drive you mentioned, when we get warm, moist air on the inside of a shower and we have cool, dry air on the outside, it's a natural occurrence, and we do get vapor drive. Now that that's all sealed up, that is that perfect environment for mold or mildew to just start growing there. A couple of pictures of wall cavities, the back of a wall where this is all green mold and mildew and everything. That's the back of drywall. This is the other side of that. It had a FRP type board on it, Flying J truck stops. They claim they see about 15 showers a day in each stall. So it's a great environment to kind of poke at. But this is not the shower. The shower's 10 feet on the other wall. This is just vapor drive that's getting pushed into that wall. And that FRP board was kind of keeping that moisture there and creating this issue. It rotted all the metal studs out of the bottom of that. And then this is just another example. Again, not a shower pan leak issue, but you can see these studs had rotted to the point that the mixing valve could just move around in there. And this is all just vapor drive. So it's important that we not just talk about waterproofing when we consider that's vapor, right? So the different shower systems available to us. On the left, we have water in, water out. This is the traditional system that most all of us know. We have a pre-sloped mortar bed with a pan liner, then a second mortar bed that all goes to the drain assembly. There are weep holes that these spacers are protecting. They're supposed to be protected with this or pea gravel or something else to keep the mud from packing all around those. In 25 years of installing them and seeing others installed, this does not get done ever. We pack that with mortar right tied up around the drain, which clogs those weep holes, and it can't drain the way it's designed. So this is a good system. I'm not trying to pick on it as much as just point out that it was designed about 130 years ago, and we have newer technologies, every other year now that update us. We have running water inside the house now. This is just kind of an antiquated system to do, but on the right is a bonded waterproof system and kind of the way things have evolved. That Tile Council handbook, this is a detail out of it back when we were floating mortar walls, and really just pointing out there's a lot of steps involved with it. And it's very labor intense. We don't really have the labor force that can do that kind of work anymore, or we're not building structures to support that kind of weight in a lot of cases. So backer board was invented, and cement backer board was invented and kind of changed things. One of the issues that we had here when we were floating walls and everything, our waterproof layer was behind everything. Our mortar bed held all of that in. When we went to backer board, there's some of the cellulose and other things that are in it that actually wick water. Let me back up a second. I'm getting part of that wrong. The plumbing code says you can't penetrate the pan liner and the waterproofing 3 inches above the curb height, where a backer board manufacturer says we need to fasten it every 4 to 6 inches. That bottom foot can't get fastened, so what most installers would do is run the board down to the floor and pack my mortar bed up against it to slope to the drain. Once that bed gets fully wet, it starts wicking up the backer board, the cement backer board. So if you've ever seen a shower where tile's dark around the bottom part of it, the board's fully saturated, the tile's fully saturated, and it'll just keep wicking. So started from the floor wicking up. It was enough of an issue, especially with fiber cement board, that tile council went back and added this detail that it's got to be separated, and they want this to be 100% silicone filled here. So just not a real practical way of doing things on a job site. And we still have those weep holes that aren't getting protected. So I think this is a incorrect installation video. I didn't point out, but in between the studs, there's no blocking. There's supposed to be blocking there. This is just a elastic membrane, and once it ages, it's going to just fall down into the cavity of the wall cavity. But this is typically the way they get installed. There's no pre-slope. It's laying flat on the floor. We fill it up with water, test it for 24 hours, and we come back and do the rest of the assembly. It's supposed to be a vapor barrier here. We were visqueen or roofing felt are common, but here we're nailing the cement board, and this really just becomes a conduit for water and moisture at that juncture to travel right into the framing. At the curb, there's no detail in any handbook on adding cement board to a curb, because as you can see, we just punched 25 holes right in our waterproof layer. So this is typically the way it gets done, and this is where we get a lot of those problems that we see typically at the curb, is where tile or grout start cracking. 90% of the water will go down the drain or more, but what gets into the mortar bed's porous, and it's designed that way so that it kind of percolates through, hits the rubber liner, and makes its way down to those weep holes. Hard to tell here, but no pre-slope. This means this is actually a dam right here. This is the drain body itself is actually higher than the liner, so it will always hold water and kind of be a swimming pool of everything that gets done in the shower. So it's kind of a sick assembly. Have you torn any out that were like this, or anyway? So yeah. Yep. You didn't have more of this, or you mentioned the green board was still in good condition, and yeah. Waterproofing is a detail thing, right? It's not something to just be haphazard with. This is kind of a typical job site. You can see all the penetrations from nailing it on there. I'm not really sure if this was framed at one point and it was too narrow and they came back and added this, but these studs are not protected at all. And then on the right, this is a plywood bench. I got too carried away there. This is a plywood bench that doesn't have any waterproofing on it. And even if you put this pan liner on it, then you have the board to nail to it and just punch a bunch of holes in it. So this is it with those nail holes across the top of it. The next detail in the book was the introduction of bonded membranes, and this really moved our waterproofing layer from behind our assembly, the water in, water out, to the front of it. So our waterproof layer is now directly behind the tile or on top of the mortar bed or substrate itself. So two ways of doing it, with a liquid or a sheet applied membrane. The liquids can be a little challenging. A lot of guys like them because it's just like painting. It's very easy. The challenge with a lot of it is trying to get them to the required thickness to be waterproof. And to my knowledge, none of them are vapor proof. They're not steam retardant or deal with vapor. So with a 3/8 snap roller, you can only get about 7 mils thick at a time. Most of them require somewhere between 20 and 40 mils thick to be waterproof. So what happens in the real world is you get one good coat, and I'm coming back to set tile with it tomorrow, unfortunately, and it's easy to make it last a year or longer before there's any issue with it. So there's just some very unique things with it that make it challenging. For example, measuring it on a job site, we're measuring thousandths of an inch with a millage gauge. It's not real practical. I don't think to measure that on a job site that changes with temperature and humidity conditions and everything else. So uh, these are some of the challenges with it. The sheet applied membrane is a consistent thickness. It's not relying on an installer to determine whether it's thick enough or not. It's always thick enough. It's inorganic. Comes with some printed guidelines that just make not having to have a straight edge for everything. Uh, Again, brings all those waterproofing connections and layers directly behind the tile. So this shower will dry out pretty much immediately after you turn the shower off, and grout joints and all will be completely dry within 5 or 10 minutes. You don't have the mold and mildew issues to deal with that you did prior to that. So it does work with pre-slope materials that we have or a mortar bed. It can go over drywall or other cement board, and there's no drying time with it. It's ready for tile immediately. This comparison of it going in versus that other system, traditional system. A couple things have changed with this one. You're going to see a 1 meter roll, 3 foot wide roll going up. We actually have a 2 meter or a 6'7" roll now that you can go all the way around and just eliminate the seaming and multiple pieces. But key to any of the waterproof connections is a 2-inch overlap of the membrane to itself with full spread of thin set behind it. And we continue around the walls. One of the big things for me with a bonded system benefit wise is with a traditional system, I put my pan liner in first and then I work on top of it while I'm doing all of my work above that. With this system, I can waterproof walls, even install tile on the walls without having any of the floor in. I could just be standing on my slab or wood frame, and any tools I drop or anything are not going to damage the pan liner. And I can drop the pan liner and all in afterwards and make these connections. So preformed inside and outside corners, and then the 5-inch banding, we're kind of just making connections between all sheets or changes of planes. And really we have a water bottle at this point, where the drain would be the cap. The water bottle's upside down maybe, and so you're ready for tile without any tile. I'm sorry, ready to use the shower without any tile and not have to worry about damaging anything. So the drain body goes in and we make that connection to it. Flood testing, good idea to flood test. Of course, we encourage that a good 24 hours or so just to make sure that we are holding water before we start putting tile on it. We're also addressing the outside of the curb. This area typically is where we see a lot of initial cracking or issues with the curb. So it just makes sense to kind of carry that waterproofing layer outside. And that pretty much is it. Right. It's a pretty quick system. You can go from comparing the two with that traditional system. You tend to have about 3 to 5 days of prep work before you're ready for tile. With this system, I can start at studs and be fully waterproofed in an hour and start setting tile in within an hour and a half or so. Only for the flood test, right? You do have to let that cure 24 hours. You can use a speed set and do it in 6 hours if you're in a big rush for it. Speed set has some accelerator in it that will make the Portland kick off and cure well enough. But typically 24 hours for that to cure, just to flood test. Any of the walls that you're putting up are ready for tile immediately. I can install the membrane and start setting tile on the wall immediately. There's no drying time for it. The floor. If I'm going to do walls first, I'm probably going to run a ledger board 1 row or 2 rows up, just attach a board on the wall and start stacking wall tile there. Once that dries, I can pull that board out and make a 2-inch overlap connection of the membrane so that I'm waterproof again over those fastener holes, and then just set my floor and lower tile below it. Does that make sense? Correct.
And leave it. Don't bring the rest of the wall.
I would just waterproof the wall, put a board up, one row of tile higher, stack all the wall tile on it, install all the wall tile, and then back out, pull that board off and use a piece of the membrane to make that 90-degree connection, making sure that I get those penetrations covered, those nail holes from the board that I took down, right? Does that?
But I guess it'd be tricky to get your tile to be when you're going to finish your.
If you do it day in, day out, it's not that bad, right? I mean, it's a part of the process, right? A good tile guy should be able to finish this or this either way and not having an issue with it. It can be a little more challenging, but it's a benefit of not having to work on a material that is your waterproofing for everything until you're ready to cover it up with tile.
Or you could just wait it out.
You could, yes.
If you're not in a hurry.
If you're not in a hurry, you could do the whole thing, even start tiling the floor, let it dry, and then work on top of it as you're setting your walls up. You can do it either way.
Meaning that time is not the issue, there is no hurry. Would you lay the floor first and then go up the wall, or would you do the wall and then the floor?
Makes no difference, really. It just depends on your particular situation or preference in a lot of cases, right? You can go top down, bottom up, left, right, diagonal. As long as you get the 2-inch connection overlap, you can do it any way you want to. That's that. The drain assembly and the membrane will come with all of these parts and pieces. Those are the system itself, the drain and the membrane. All the other styrofoam are just accessory pieces to make things a little easier. Take some of the labor and the weight out of it. So, correct, just the board. I don't think I get to the board in this with it, but the board comes already waterproofed.
Do the wall, do the whole wall.
Yep.
And then come back and do the floor, making sure you got 2-inch seams.
Correct.
And let all that stuff dry.
Flood test it.
Yeah. Flood test it.
Yep. And then you're ready for tile.
Because all of it, I guess you just put water on it and let it sit overnight and see how much.
Yeah, you'll fill it up typically to a mark, some determined level. It's usually 2 inches above the drain height is what most plumbing code is. Make a mark, and then you'll come back in 24 hours and see whether it's.
I'm not having a curve, so it's going to be tough to flood test. It's going to hold water.
Well, we can still flood test, right? We take a piece of the membrane and make an L shape out of it, attach the bottom with mortar so that we have a good connection there, and then just use bricks or board or something to prop up the backside of it. Fill that with water and let it do your test, and then you can come back and just cut the edges and fold it down, then set it down, and then set tile right over it.
Okay. Yeah, so
It's just a temporary. It's just a temporary dam to contain it. Yep. Yes, it is. It is. So a lot of different drain designs and materials, from stainless steel, the aluminum. This is a tileable version, so we have no visible metal. The drain slot's just the open grout joint around it. It's a nice look, right? And some newer designs, metallic finishes, gold's coming back. We're seeing rose gold, vintage gold, classic gold.
Yeah, they were pretty good. And then he's got the ones that
They're
the pattern matches.
the shelves patterns are now matching the drain grate patterns and finish, and then that also matches the profile finish. So you can kind of color coordinate all the way through the shower. 4-inch options typically, but also have the 6-inch and stainless steel. ABS or PVC, stainless steel with a no hub connection or a threaded outlet. Those are all vertical.
What would be the difference between the threaded and no hub?
This no hub has a rubber boot, essentially a Fernco fitting that goes around the outside of it, and it uses a clamp where the thread it's going to thread onto a pipe that's already there. It depends on what the plumbing is doing in the building, I guess, most of the time. Well, correct. Correct. Yep.
This rubber,
It is. It's just, it replaces a glue connection. It's a boot about 4 or 6 inches tall that the drain body will slide into, and then the drain pipe will slide into, and they've got clamps on either side to tighten it down. Those are vertical. This is a horizontal drain. And in Europe, this is more common, I guess, that they take their floors with them, kind of is what we're told. They relocate plumbing all the time on top of the slab. We don't do that here, but there is a drain now for that. And where it comes in handy is if you think about vertical living, high-rise stuff where maybe it's post-tension or pre-stressed slab that you can't jackhammer or do anything with, or you don't want to cobble something up like this. So that drain lets you just come up on top of the slab or wood framing and move the drain over to wherever you want it. Right? You can relocate it anywhere in the bathroom. There's a compensation board that kind of covers up the plumbing itself. This all goes down to this and comes all the way through.
And I guess it's not going to really move fast, but it will move fast enough not to fill that mold over.
Correct. It all slopes at 1/4 inch per foot. That's what plumbing code requires. So all the trays, and of course that plumbing would have to be kind of installed at that slope. So those are glue connection drains that we were just looking at. This is an adapter drain. If you have an older style 2-stage clamping drain in place already, this would just let you get rid of the top piece. This would bolt back up to it, and then our drain just is a compression fitting. Correct. Yep. Both for a 2-inch drain or a 3-inch drain outlet. So another floor drain that was really designed more secondary or overflow type drain, something that doesn't really slope to the drain, but more flat floor application. PVC and stainless steel options for it. Line drains have been a common trend. They're up to about 6 feet in length now and have some pretty nice designs. The big benefit with a line drain is that we're sloping one direction, and we can use a large format tile now. It doesn't have to be a mosaic or a smaller format tile to conform to that conical shape of a shower floor. And we can do it at the back wall or at the entry or in the center. A lot of different finishes and even that tileable option for it. Looks really good. And then this Vario is a brand new drain that really lets you separate or relocate the drain itself. The drain body could be here or here or here, and then the grate's just going to cover that and make it look like the drain is wall to wall with it. Same designs with it. Prefabricated substrates. These are eliminating the mortar bed or accessory pieces to make installation a little quicker. Center drains or offset drains. These are line drain trays. So it's just styrofoam. It's real easy to cut to fit a smaller footprint, or we can extend it with dry pack and then put the membrane over top of that and make those connections. Curbless applications. So this is our whole shower footprint with all the waterproofing. This is an uncoupling membrane on the outside floor, and we make a connection between the two. So essentially your bathroom is a shower pan, right? Everything's waterproof up to the door. This is all flat.
So did you put the membrane extending past the shower?
Correct.
So I will have to do that too?
The preference is the whole floor, right? For a couple of reasons. This is a membrane, forget the shower for a minute. This is a membrane we use on every substrate, concrete or wood, to eliminate cracked tile or grout. Any movement in the slab, any crack in the slab, or movement in wood from temperature change or moisture change or just loading, this absorbs that movement and eliminates any cracked tile, right? So we're going to use this everywhere.
It's not on wood.
Okay.
It's all concrete.
But we joke about concrete. Really, there's only two types of concrete: concrete that has cracked and concrete that's gonna crack, right? We just don't know when or where. You can treat a crack today. That's kind of a Band-Aid approach to it. But when you tile over it in 6 months or a year, it may lightning bolt off to another side. Uncoupling just comes in and treats the whole area. And we're not concerned what the slab does. As long as it's structurally sound, it can move and not affect the tile layer.
Membrane all the way through
Every-
the entire floor.
Everywhere you're going to tile, everywhere that you're going to put tile, right? Keeps it from cracking. And then the other benefit in this application is that we can waterproof it from the top side. It also manages vapor from the underside. So if you had a slab that no vapor barrier, or you have a high water table, something's going on, it manages that vapor from the underside also.
All right, so it's already too late. 'Cause I guess I would have to put that membrane all throughout the house.
Well, ideally, yes, but you can stop at the doorway and just transition. We have some transitions that will go from one elevation to another. If you're okay with a minor, it would probably be 1/4 of an inch transition. We make some ramp reducers that go from one elevation to another that would help with that, or other threshold.
That I was using is the membrane, the thinner.
It's roughly 1/8 of an inch, 3/16 of an inch thick. And well, the Curdy is just the waterproofing. This is Curdy, and this is uncoupling.
Yeah,
Oh.
there's a difference between the two.
Yes. One is just waterproofing, where the other can be waterproofing, but it also allows for that movement to
Yeah, I've seen
happen.
the video with the little triangular shapes.
Yep.
Just-
They're dovetailed so that when they're filled, mortar dries in there and it creates a mechanical anchor.
But from a waterproofing conversation, and vaporproofing,
Waterproofing solely, you could do the membrane over everything.
the wet area.
The industry says that you need to come a minimum of 1 foot outside the shower footprint with the waterproofing.
So what I'll do is when I'm gonna do my flow test, because my
Right.
shower looks very
Yep.
similar to that.
Right here.
I'll pass it, a foot or so past it.
Yep.
Use that material, prop it open. and keep it
Correct.
over my-
Correct. And then just fold it down.
Once it's past it, I'll just fold it back down, then set it in place.
Yep.
The whole shower's gonna do exactly what you got there.
Okay.
Flow into it with a linear drain in the front.
So I think we looked at some of the profiles over there. The one I wanted to point out while we're here and talking about it, this is the one that we put the glass in. So instead of having the glass guy come and penetrate the waterproofing and fill it with silicone or something that's just not going to last, this is a profile that goes in with tile on top of the membrane and just eliminates him drilling holes or damaging the waterproof layer. So
So you
Just-
put that piece on top of the top.
thin set. No, it goes in with thin set, just like we're setting tile. You can just think about it like a piece of tile.
You set the tile, you set the glass wall, and then put the tile around it.
No, you're going to set that channel. There's a metal U-shaped channel that will set right under where the glass is going to be.
So it's flush.
It's flush with the tile's going to butt right up to it, and then the glass would sit right down in the center of it. So you don't really see it at all. Right? And it's solid. It's not going anywhere, but we're also not drilling holes in any waterproofing. So
I was-
that's a better way, right?
Now that's a way better, 'cause I was battling in my head how I was gonna do that.
It
Because I got no problem with the wall,
right.
you know.
Vertical hinges are different, right? Water's going to run down that way, but anything on a horizontal, we shouldn't be penetrating it, period. Really. Slope to the
I was
drain.
supposed to set it on top and then just glue
Yep.
it or just,
Yep.
you know, I have no idea.
Several different niche sizes, and I'm showing you here the LED niches. This is something that's recently come out.
Everybody will say,
I think so, yeah.
"They have it in the shower."
Yeah. Yes.
Right on the shower.
It's kind of crazy. We do heated floors also, and people use heat in your shower. And you don't really get the benefit of the heat on the shower floor because the hot water kind of heats it up and you don't really feel it. But the bench where you sit down, that's a big difference when your cheeks hit, a warm bench, 80 degree, 85 degree. It's a nice thing. Okay. So I think I was there anyway. So thank you guys. I appreciate it. Absolutely. I'm glad for you guys to hold it down. You were a rough crowd, but we got through it. So.